Hi ladies, it's Mr. O'Sullivan. Today we're beginning a new unit number 5, Systems of Equations. So when we look at systems of equations, we're going to be looking at a bunch of different ways to solve them. We're going to be looking at substitution, elimination, and graphically. We're also going to be looking at some systems of inequalities as well. Today's learning target is I can solve systems of equations by using substitution. But before we begin, we want to make sure that we actually know how to do a few things. So for this warm-up we're due now, we're going to answer these two questions. Question number 1. If f of x is equal to 3x minus 4, then evaluate f of negative 5. So what we're saying is that we want to see what happens when we plug in negative 5 everywhere we see an x. So what we're going to do is we're going to just do f of negative 5, and we get 3 parenthesis negative 5 minus 4. So I can ask you to do this using PEMDAS in your order of operations, or you can just type this into your calculator. When you type that into your calculator, you get 3 times negative 5 is negative 15, and then when you subtract a negative 4, you get negative 19 as your final answer. Try to do the next one by yourself. When you do this one by yourself, you're just plugging in a 2 for x everywhere you see it. So I have 4 times 2 plus 6 times 2 squared. Again, you can just type this in your calculator and see what you get, or you can use the order of operations. When I do 4 times 2, I get 8. When I do 2 squared, I get 4, so I get to do a 6 times 4. 6 times 4 is 24. And then 8 plus 24 is 32. And that's your final answer. So what I'm going to ask that you do when you do your EdPuzzle is that you're going to describe the process that we use to evaluate both of these examples above. Something along the lines of, to get my final answer, I just plugged in. Were substituted. So now, when you do this, we're really just going to be using substitution. So it's very important that we're familiar with how to substitute a value in for a variable, or when we plug in an expression for a variable. So when solving it by a substitution, equals may always substitute for equals. So whenever you have something along the lines of y equals, or x equals and x equals, all you're going to do is just set them equal to each other. We're just going to set them equal to each other. Now, what is the answer to systems of equations? Well, if you look, this is an example of a systems of equations. I have y equals 2x minus 1, and I have 3x plus 2y equals 26. So if you look, we have an x value and a y value. So those are going to be our answers. And we like to write our final answer as an ordered pair. And just when we get to solving these graphically, it is the point where your two lines intersect. Let's go on to this procedure. So before we begin, please make sure that you find the answer for all variables in the problem. So if we're talking about A's and B's, I better see an A and an B in your final answer. If I see X and Y in your question, I better get an X and a Y. So what we're going to do is go through this procedure. So when we do this example, we have y equals 2x minus 1 and 3x plus 2y equals 26. The problem is already solved for us. Let's look to see the procedure. Step 1 says isolate one of your variables. Isolate your x or your y. So what we mean by that is we want it to say y equals or x equals. If we look at our system, we have y equals 2x minus 1. So it's already isolated. Step number 2. Substitute the isolated expression from step 1 into the other equation. The resulting equation should only have one variable, just an x or a y. So if you look, what I'm saying right now is y is equal to 2x minus 1. So everywhere I see a y, I'm going to substitute 2x minus 1. So what we did right here was we have 3x plus 2y equals 26. I'm saying that y is 2x minus 1, so we're going to plug it in right here. Now that I have a 2x minus 1 in parentheses and a number attached to it, what we're going to do is we're now going to solve this new equation for x or y. In this case, it's x, since everything's in terms of x. We distribute our 2 to both terms. 2 times 2x is 4x, and 2 times the negative 1 is a negative 2, so I have 3x plus 4x minus 2 equals 26. What I then do is I combine my like terms. 3x plus 4x is 7x, and then I get 7x minus 2 equals 26. Only way to get rid of my minus 2 is to add 2 to both sides of my equation, and then I get 7x equals 28, and then I divide by 7 and get x equals 4. Now that I solved for x, we're now going to substitute the value we just found into either one of our equations. Here's what Miss Townsend and Miss Jimenez and I like to do. We like to plug it into the less busy equation, or the less complicated. If I look, 3x plus 2y equals 26 is definitely much more complicated than a y equals 2x minus 1. So I'm going to choose my y equals 2x minus 1. If you look, we said x was 4. So everywhere I see an x, I'm going to plug in a 4. So I get y equals 2 parentheses 4 minus 1, or 2 times 4 minus 1. 2 times 4 is going to give me an 8. I then do 8 take away 1, and I get a 7. So this is acceptable if you were doing a worksheet where you can write x equals 4 and y equals 7. On Delta Math and on Desmos, what we're going to expect is that you write it as 4, 7. And that would be your final answer. Okay, let's go on to these examples. Solve each of the following systems of equations by using substitution. If you look in our first example, we have y equals 2x plus 5 and y equals negative 3x minus 10. I said this before. Whenever you have y equals or x equals or y equals, x equals, you just set your two equations equal to each other. So let's just write a quick note. Set equal to each other. So I have 2x plus 5 equals negative 3x minus 10. And what I'm going to want to do with this equation is get all of my x's on one side. I prefer my x's to be on the left-hand side of my equation. So I'm going to add a 3x to both sides. And then I get 5x plus 5 equals negative 10. What I'm now going to do is I want to get my numbers to the right-hand side of my equation. So I have to ask myself, how do I get rid of that plus 5? I'm going to take away a 5 from both sides of my equation. And I get 5x equals negative 15. And then our last and final step is we divide by a 5 on both sides of our equation. And we get x is equal to negative 3. Here's the issue. That is not our final answer. We just know that x is equal to negative 3. We want our y value now. So what we're going to do is we're going to pick a favorite equation. What I'm actually going to do is I'm actually going to use both equations to show you that it'll work either way. So I'm going to rewrite my y equals 2x plus 5 and my negative 3x minus 10. What we're going to do is we're going to plug in a negative 3 to both of them. So we have y equals 2x plus 5 and a y equals negative 3x minus 10. Everywhere I see an x, I'm going to plug in a negative 3. What I get is y equals 2 times negative 3 is a negative 6 plus 5. So I get y is equal to negative 1, because negative 6 plus 5 is negative 1. And then when I do the exact same thing here, I get y equals negative 3 times a negative 3, take away 10, Negative 3 times negative 3 is a positive 9. Nine minus 10 is negative 1, which is exactly what I got in the other equation. So my final answer for this would be, make it a little bigger, negative 3, negative 1. And that's your final answer. Let's go on to our next example. I have 4x minus 2y equals 16, and y equals negative 5x plus 13. So the first question I have to ask myself, do I have an equation in the form y equals, or x equals, where y or x is just by itself? And I do. I have y equals negative 5x plus 13. So everywhere I see a y, I'm going to substitute a negative 5x plus 13. So what I like to do is I like to rewrite the equation I'm going to substitute into. So I'm going to write 4x minus 2y equals 16. I'm now going to substitute that negative 5x plus 13 in for y. So I have 4x minus 2 times negative 5x plus 13 equals 16. I'm now going to distribute my negative 2 to my negative 5x and my negative 2 to my 13. And I get 4x. Negative 2 times negative 5x is a positive 10x. And then negative 2 times a positive 13 is a minus 26. And that's all equal to 16. What we now do is we combine our like terms. My 4x and my 10x. 4x plus 10x is 14x, sorry, not 16x. And I take away my 26, and that's equal to 16. What I now do is I want to get x by itself, so I'm going to have to add 26 to both sides. When I do 26 plus 16, I get 14x is equal to 42. And I'm going to divide both sides by 14. And get x equals 3. So now that I know x is equal to 3, I need to find out what y is. If I look, I need to ask myself, what's less busy, my first equation or my second equation? You can use either one. I like to do the easy thing. I'm going to do the second one, y equals negative 5x plus 13. Now that I have y equals negative 5x plus 13, everywhere I see an x, I'm going to substitute a 3. So I have negative 5 times 3 plus 13. Negative 5 times 3 is a negative 15, so I have y equals negative 15 plus 13. And then negative 15 plus 13 is a negative 2. So my final answer is x equals 3, y equals negative 2. And that's your final answer. Remember, write your answers as an x comma y. And if you have any questions, please email myself, Ms. Townsend, or Ms. Jimenez. Don't forget to finish this EdPuzzle and watch your Delta Math. Do your Delta Math. Have a great day, ladies.